Sometimes I forget things just as soon as I say them, but believe it or not, your computer can do the same thing. Why is it happening? Find out more next.
You're watching IT Pro TV.
Did you know that your computer can have short-term memory loss? Did you know that I can have short-term memory loss? Well, the reason for that is something that we call random access memory. And why does that actually happen? Well, this is the man that actually can let you know that, and that's Mr. Wes Bryan. Wes, this is kind of one of those subjects where everybody says, I know that I need RAM, but they may not know exactly what that means and what we actually have to know about it. So how are we going to tackle this?
So we're going to couple this with a little bit of show and tell. We're going to talk about what random access memory is for us, why it's so important, how we utilize it, as well as we're going to talk a little bit about specifications surrounding random access memory, because there are some industry standards. Of course, big surprise there, right? And then we're going to look a little bit at where do we actually find that within our system units.
All right, it sounds like a lot for us to discuss, so head on over to the bench.
All right, everyone, come on over here and join me. And this is one of those episodes that really does deal with specifications. You know, just like any other technology that we look at, everyone out there, you have to kind of learn the language. You have to learn the jargon so that you understand. If we were to say, hey, I need you to get that DDR4 module out and install it in that DIMM socket or DIMM slot on the motherboard, would you know and be able to identify that scenario and come up with the right answer? So what we're going to do, and what I thought would be nice, is just to have a general discussion around RAM, not a lot of diagrams, if you will, and let's just start there. When we talk about RAM, what is RAM? You've kind of heard Ronnie alluding a little bit to it, but it's called random access memory. And random access memory is a type of memory that we've been using for our main system memory for a very, very long time. And these components don't really look like much. They're just little modules, if you will, on look like little chips, right, on a printed circuit board that gets inserted into a slot on the motherboard. And that's a lot of times that's all we see, right? But random access memory, right? It is what is known as a volatile storage mechanism, right? And what we mean is volatile, right? When we say volatile, what does that mean? Well, that means that we need to have an electrical current established and actually on that storage location to retain the information that's within it, right? That's what volatile means. Unlike maybe we say our hard drives, right, our solid state drives. These are non-volatile storage locations that we can use and store our information for reuse at a later time. Random access memory doesn't work that way. I want you to think of random access memory as more of this temporary workspace, right? I got a workbench here, right? And I'd like to throw things here up on the bench here and show you all, you wonderful viewers out there, and the bigger the bench, the more stuff I can put on it, and the more stuff I can show you at one time. Well, believe it or not, your random access memory kind of works that same way, right? The more data that you want to actively be working with at one time, the more RAM, the more random access memory you're going to have within your systems.
And Wes, an analogy I like to use is kind of the little joke that I was making during our introduction here. It is equatable to the idea of short-term memory. RAM actually does help us in that way, where as long as I'm actually using it at that point, it's going to stay right there and available for me to use. It's just like when we're in the middle of a show, understanding what it is that we have to do, all the stuff that Wes is actually recalling is actually right there in his short-term memory. But as far as long-term memory goes, a lot of this has been built in over time, as Wes has taught this course over and over again over the years, and what ends up happening is that that now gets stored in long-term memory as well. Things like a hard drive is kind of that same equivalent. So when we start talking about that idea of random access memory, he's letting us know the more memory that we have, the more things that we can do at one time, which is something I would love to actually say that I have more of, but as I get older, I'm starting to realize I don't have as much as I think. So hopefully that analogy helps.
Most definitely, and thank you, Ronnie. You know, I think I'm suffering from a little bit of that myself as well. And one of the things I want to talk about real briefly is the best practice, right? When it comes to installing your memory, in fact, let's take a close-up view. I've got a motherboard here, and what we can see in that motherboard is that I actually have four what are known as DIMM sockets. We'll talk about what that acronym means here in a second, but I want to talk about best practices. It's best practice that if you're going to install RAM modules, that you install the same RAM, the same speeds, because it's important to understand that if I have 3 memory modules that are installed and I install a 4th memory module that's lower speed than these other 3, all 4 memory modules are going to operate at that lowest speed. So that's very important to make sure. It's one of the best practices when it comes to installing memory. Remember, if you install a lower speed module, that's going to cause all of the other modules to default and operate at the lowest common speed.
Now, Wes, you just showed us a motherboard right there that also has the slots as being different color.
Sure.
Could that indicate something for us?
It can, yes. And let's go back to what Ronnie was saying. Sometimes it can. We've got to be careful. Let's take a closer look here. Notice that we have a lighter gray here and we've got a black, right? This is what's known as a dual channel memory in our motherboard, right? So what does that actually mean for us? Well, what that means is that when we say dual channel, you have to recognize that a single RAM module in one of those slots has a 64-bit data path. It sits on what's known as the system bus. And that is the main communication pathway between the CPU and, well, main memory, right? And it's important to understand that each memory module has the ability to send 64 bits into the processor at one time. Now, if we have single channel architecture, then we're not really utilizing the true speed of our memory. See, our CPUs are so fast that they can calculate 3 billion calculations in a single second. There is nothing on our motherboard, not a single component on one of these motherboards is as fast as the CPU. So we use the random access memory because its access times are denoted in nanoseconds, right? Very, very fast, lightning fast storage. But we can increase the performance of this volatile storage mechanism by having multiple channels, each feeding in a separate 64 bits at a time. So I want you to think of it this way. All of your memory either does one of two things. It either talks to a memory controller hub, which controls access in between the CPU and the main memory, or even Intel sometimes today literally just puts their memory right on the system bus. So depending on the architecture, all right? Imagine that highway, that one-lane highway, if you will, is 64 bits. And I can pipe in 64 bits as fast as this memory module and the CPU can work with it. Imagine if I took and put another highway right next to that one and we were piping in 64 bits on that highway. Now we have 2 data paths that are utilizing 64 bits, essentially doubling the bandwidth to a 128-bit data path. That would be dual channel versus single channel. And then you have triple channel, right? Now I think we're talking 192 bits, I believe is what that is, right? 64 times 3. Then you have also quad channel architecture. And that's like saying that we're going to have 4 separate data paths simultaneously pushing information in and out of the CPU. And that's what multi-channel architecture. And back to Ronnie's question, if we look back here, you can see that there is a color coordination sometimes. I got to be careful with the sometimes, right? It has become commonplace to color code these, so they let you know that the 2 gray ones here, the lighter gray ones here, if I install only 2 modules and I want to take care or I want to take use of those 2 64-bit data paths, then chances are I have to install 1 in the gray and 1 in the black here, right? Because they're both on their separate data paths. Now, that's not always the case, and I'll tell you why. You do have some just basic commodity type hardware like the one that we have here that sometimes they're all the same color, and what you need to pay attention to is the vendor specifications. Because typically the RAM or the DIMM slots on the motherboard, which is what these slots are, we're going to talk about that in a second, we'll say DIMM 0, DIMM 1, DIMM 2, DIMM 3, DIMM 4, and then what they'll tell you is install, to take advantage of multi-channel architecture, install 2 modules, one in DIMM 0 and one in DIMM, let's say 2. And again, I'm just kind of making these up. Pay attention to your manufacturer. Now, what if you're going to populate the same memory type, same memory speeds across the entirety of all of the DIMM slots on the motherboard? Well, then you don't have to worry about it, right? You know you're populating them all, so you have them installed in what is called the right order, all right? So that's multi-channel architecture. You have single, you have triple, or single, dual, triple, and even quadruple channel architectures today. And the quadruple channel architectures are what we see in things like Intel's i7 processors, and we'll talk about processors at another time. Now, I keep mentioning, Ronnie, you know, it's one of those things that sometimes if you've been in the industry for a while, you kind of take it for granted. I keep mentioning the terms DIMM, right? Well, what do we mean by that? Well, the form factor, if you will, DIMM donates on our motherboard here the slot type, the form factor slot type. That's called a dual inline memory module. And in our desktops, our workstations, and our servers, these are what are known as DIMM modules, right? Dual inline memory modules. But that isn't the only one that we have. And if we take a bird's eye overhead view, you can see I also have another type of form factor here, right? And this is called SODIMM or SODIMM, depending on how you would like to say that. When we talk about SODIMM, what we're talking about is small outline dual inline memory modules. And if we look at these, we'll take a closer look at these, and let's look at these side by side, and we can see. Notice that the DIMM module is about just roughly about half the size of the SODIMM is about half the size of the full-size DIMM module. The SODIMM modules are what we utilize inside of our laptops, what we utilize sometimes in printers as well. And by the way, printers can also use full-size DIMM slots as well. But the DIMM sockets are typically what we see inside of servers and workstations, desktop, just normal desktops, if you will. SODIMM or SODIMM, these are going to be what we see inside of our laptops. So that's a little bit about the form factors. Now, we also have to talk about specifications and standards. And again, ladies and gentlemen, I put a lot of this information inside of the show notes so that you can make some reference, some flashcards for your own reference, and I would encourage you to study these. There is a memory corporation, consortium, that has overseen the standardization of memory for a very long time now. They're called JEDEC. And they have some standards that if you're first getting into the industry can seem a little confusing because they define two different standards. They define the RAM chips, and what I mean by that is quite literally the little black flash memory type chips that you see on here, and they also define the completed module. And these are two different naming conventions, all right? So you're going to hear something, and if you're looking at things like objectives, if you're doing some research and you're out there maybe going to spec out a computer, you're going to see terms like DDR2, DDR3, DDR4, and even today, potentially DDR5, even though at this time the recording DDR5 is still kind of in draft and hasn't been completely finished. So what are we talking about? We're talking about the concept of double data rate. Now, I put in the notes a retro naming convention just for you. There's also one called SDR RAM. That's single data rate. That was something that they did after they came out with double data rate memory. They retro named the earlier one that was just single data rate. I'm not worried too much about speeds or anything like that when it comes to single data rate, but I will tell you, for a certification endeavor, it's going to be important to know, and let me just zoom in here real quick. See the pins that we have there, the copper conductors there?
The shiny parts.
Yeah, thank you very much, Ronnie there. So those pin counts on a certification exam mean something. I will tell you, if you're speccing out a motherboard, match the RAM to what the motherboard says and you're doing good. However, between the different standards, you will find sometimes the pin counts are identical. However, what's not identical is that little notch right there. And that little notch, if we stay close up here, actually lines up with the notches that you see over here about halfway through the DIMM slot there, right? And that's one of the things that we also have to keep in mind, and that's why it's important for a certification endeavor that you know that some of them might have the same, some of the standards might have the same pin count, but they are not backwards compatible with each other because they are notched in different positions purposely to ensure that you don't install the wrong RAM. Now, why do we care about standards? Well, we care about standards because they define the electrical capabilities and the transfer rates of these DIMM modules. There is what is known as DDR. DDR, by today's standards, is considered legacy, and even DDR2 in all transparency. But again, if it's a certification endeavor you're going for, you have to prove that you know the jargon and the lingo and you can speak the language. So I want you to remember that SDR, single data rate, 168 pins. I want you to know that DDR is 184 pins for DIMM modules, but a little bit different for our SODIMM modules in the standards that we'd be putting in our notebooks and our laptops. That would have been 200 pins. You will also see some interesting designations for DDR. You might see something like PC 1600. What does that mean? Well, DDR actually is the standardization of the chip that is on the module itself. The completed module, JEDEC also standardizes. So when you see PC dash and a number, that number that's at the end of it is the overall bandwidth that that module can produce. So when we say PC 1600, that means it can produce 1600 megabyte transfer speeds per second, right? So know that that's the difference between the DDR standard and the PC standard. And you'll start to associate these with what the DDR equivalent is. So for instance, if I took PC 1600 and I divided 1600 by 8, I would get what the DDR equivalent is. That would be DDR/200, right? It would be DDR-200. So I put some of the PC standards in here for DDR, double data rate RAM, if you will. But then they doubled the speed, and one of the things that a lot of these successive generations of DDR standards do are two things. They improve the bandwidth, but they also reduce the power consumption, the power requirements. They can do that at a much lower voltage. So with DDR, I want you to remember that the DIMM modules have 184 pins. The SODIMM modules have 200 pins. When we get into DDR2, it's double data rate 2. It doubles over the earlier speeds, and we have 240 pin DIMM modules with 200 pin SODIMM modules. Now remember what I said, everyone out there, that you might have some standards that have the same pin counts, but the notches are not the same, and that's true of DDR2 and DDR3, because DDR3, yes, doubles the data rate again, DDR3, double data rate 3, but it also reduces the voltage and it moves that notch. So we have 240 pins for DIMM modules, but the SODIMM modules are 204 pins. So there is a slight difference. One of the great things about the DDR3 implementation that I want you to be aware of is it increased the amount of RAM that you could have in a single DIMM module, 16 gigabyte DIMMs. So you could have a potential to have 8 DIMM sockets on a motherboard, and each one of those DIMM slots could potentially be housing a 16 gig module. And that is one of the great things about DDR3. Now when DDR4 came out, which is what this motherboard is and what this motherboard is, DDR4, there wasn't really much of a speed increase. They kept the speeds around the same, but again, the voltages dropped a little bit more, and the per DIMM module, are you ready for this? 64 gigs in a single DIMM module. So if you had 8 modules on a motherboard, multiply it times 64. It's a massive amount of memory that we can get on a single system today. And the pin counts are up to 280 for your DIMM slots, and your SODIMM slots are going to be 260. And I also in the show notes have some of the module equivalents. So you'll see that DDR2 is PC2, DDR3 is PC3, DDR4 is PC4, and you'll see some of the equivalent module standards in the show notes as well. Now it's interesting because objectives call out DDR5, Ronnie, but it is not completely finalized. It's not a standard, but I can give you a little bit for the exam so you'll be prepared, because one of the things I do know is that the pins stay the same. As far as the capabilities, we've yet to see that. It'll probably be another one where they're reducing the voltage requirements, and they're starting to do things like predictive data anticipation. Things like, well, in some of the earlier modules, they would use things like prefetch. Well, that technology is actually advancing. So there's ways that they can anticipate what's coming, and they can increase the bandwidth as well. A little bit more than what you need to know for this exam, but me, I love the technologies. I absolutely think they're great. So with that being said, Ronnie, what do you say we go ahead and kind of show them where the RAM modules would be located? And ladies, or just everybody out there, I just want you to know that we realize that there's a lot of specifications here. We've got them in the show notes. Please take the time to make some flashcards and get this information under your belt. So if we go to a bird's eye view here, I'm going to remove the case cover here to this PC. And what you're going to see here, if we can zoom in just a little bit, there, thank you very much. We've got two RAM module or DIMM slots in this motherboard here. And what you have are these two levers on the outsides of each one of these DIMM modules. You can see there's white and black here, but this one has a white lever here that I've already pressed down because I've got pretty big hands getting into this case, and one that's pressed down on this side too. And that allows me to remove this RAM module. And you can see what we have here is essentially we've got a DIMM slot or a DIMM module. This is a DD, and let me just double check, I'm telling you right here. Yes, this is PC4. And you know what? Let's go ahead, let's go even closer. Let's see how really close we can get on this, Ronnie, because I'd like to see let them see that PC4 designation. You see that right there? That says PC4 3200, and then it's got some characters at the end. That's essentially an 8 gig DDR4 stick, right? And you can see that the chips are DDR4, but the module itself completed, we can see right there is PC4 3200. So that's some of the equivalents I wanted to show you. First of all, to show you where in our system case is the RAM even located, and then what are you talking about when you say DDR4 versus PC4? So you can kind of see how they stack up. Those are for a certification exam. Ronnie and I were talking about before we started. At the end of the day, once you've passed your certification, or if you're currently in a support role, you're going to be just look at the model of the motherboard, look at what it says it requires for RAM, and make sure when you purchase it and you implement it, you're implementing the same speed of RAM across the motherboard so that you get the full performance out of the RAM sticks that you're buying.
Yeah, when it comes down to it, that's pretty much what we're going to experience as just somebody supporting a regular desktop. But Wes, as an IT professional though, there may be times where we actually go into different types of machines such as servers, and we might find out something, even though the RAM looks the same, we might actually see that they're not the same, right?
That's very true. In fact, what Ronnie's talking about here is a really cool technology. I love technology. I hope you do too. And that's something known as ECC-based RAM. Let's go ahead and set the stage before we talk about what ECC RAM is and understand that they are two completely different types. And I like what Ronnie said, because going out the gate, you might look at it and they might look identical. So what is the difference, right? Non-ECC RAM is the RAM that we're looking at right here in our workstations, right? It's relatively inexpensive. I know money's always relative to, if you don't have money, everything's expensive, but relatively inexpensive. However, in our production level servers, right, our machines where our data is so crucial, we want some type of RAM that allows us to check the quality of the data, check the integrity of the information. And if that information has errors in it, apply some kind of algorithm or solution that can fix those errors, and that's where we have what's known as ECC RAM. So when we say ECC RAM, what do we mean? We mean error correcting code. See, ECC RAM is really good, and if you haven't seen a server boot up, it's kind of interesting on how it does it. It actually will, as it's going through its post and BIOS is kicking off, or UEFI is kicking off all the hardware and stabilizing it, the memory controller will send a little bit of data into a memory bank within that module. And then it'll try to read that information out and compare the two values and find out, are they matching? And if they're matching, then it knows that that's good quality error correcting code RAM and that we're all good and we can proceed with the boot process. So error correcting code RAM is typically a lot more expensive than your common desktop RAM, and they do not mix and match. You do not mix non-ECC, normal workstation RAM, with server ECC memory because they are not compatible with each other, and that will cause your systems not to boot. So ECC RAM is something that I would also be aware of. Ronnie, there's one final thing just to throw a rock in the calm pond of understanding that I want to mention, and that's this concept of virtual RAM, all right? We have to really be careful, right? Because today's day and age, we talk about things like virtualization and virtual machines and supporting virtual machines with having virtual RAM. That's not the type of RAM that they're talking about in this context. What they're talking about is what we call virtual memory. I like that term a little bit better because it tells you a little bit more about what we're doing here. Virtual memory is this trick, I like to say. It's the wizard behind the sheet, if you will. And virtual RAM, at the end of the day, it allows us to provide a small portion of our hard drive or storage device, could be a hard drive, could be a solid state drive. The mechanism isn't important. But the part of our internal storage media as a portion of RAM. Now, we still use this today. It's still built in our systems into what's known as a paging file. But it was very critical in the days when maybe you only had 512 megs of RAM, right? We don't think about it today because we have systems that have I'm sitting here with a very low-end system that I bought, and it has 32 gigs of RAM. So that's kind of archaic today, but you should know that our systems still use what's known as a page file, so that when the RAM starts to fill up and we have no more physically installed RAM to use, there's a piece of software called a virtual memory manager, and what it can do is it can say, all right, the physical RAM looks like it's full. I tell you what, we'll take this information that's not currently being used and we'll write it to the hard drive, and then we'll find that application that's looking for information in RAM and we'll write it into the RAM, and I'll swap that in and out, and the applications can continue to work. Microsoft recommends that you set your page file, that virtual memory location, at 1.5 times the size of the installed RAM. Now, that being said, today's day and age, if I have 96 gigs of RAM on a motherboard, I'm probably not going to allocate, what would that be, like about 100 and let's say 40 gigs-ish
somewhere around
to a page file. And that's a lot, right? So whether you use it or not today and actively set it to that 1.5 times the size of the physically installed RAM, you do have to know that your operating system is using a portion of your hard disk or your solid state disk as though it was physical RAM in something known as virtual memory, and it is being swapped in and out by a component within the operating system called the Virtual Memory Manager. It allows systems that are limited on memory to allow them to continue to work even when the physical memory we start to hit its limitations. These are some of the things that I would know about your random access memory. Utilize your learner notes for specifications when you're sitting the certification exam. Those of you that are in support desk roles, match the RAM module to the motherboard, and at the end of the day, you're going to be doing well.
Thank you for watching IT Pro TV.